I run a small daily podcast for local news aggregation, and for a long time, I was manually recording the narration. It was tedious, inconsistent, and frankly, a bottleneck. I needed a fully automated solution that could take a raw text script, synthesize it into natural-sounding audio, and do so with a consistent voice that my listeners would recognize. The goal wasn't just to replace my voice, but to build a system that was robust enough to run daily without intervention, handling API rate limits, network glitches, and the inevitable quirks of large language model outputs. I had already built the text generation pipeline using Claude, so the missing piece was reliable, automated voice synthesis. I looked at a few options, but ElevenLabs quickly stood out for its voice quality and developer-friendly API. The challenge was figuring out how to integrate it into a production system that would maintain voice consistency across multiple chunks of text and minimize costs, while ensuring high-fidelity output. This isn't just about calling ElevenLabs.generate, it's about building a resilient audio factory. The first hurdle was script preparation. My daily news scripts were generated by Claude and could range from 500 to a few thousand words. ElevenLabs has character limits per API call, and while I could just send the whole script, breaking it into smaller, manageable chunks offers several advantages. It makes the synthesis process more resilient. If one chunk fails, I only need to retry that specific segment. It also allows for parallel processing if I ever decided to scale that way. Though for a daily podcast, sequential was fine. I wrote a simple Python function, chunk script by sentences, that uses an LTK.send tokenize to split the raw text into sentences and then groups those sentences into chunks, ensuring no chunk exceeds a predefined character limit, typically around 2,500 characters. This prevents sentences from being cut off mid-thought and keeps each audio segment coherent. It's a pragmatic approach to dealing with API constraints while maintaining natural flow in the output. Choosing and maintaining a consistent voice was critical for branding. ElevenLabs offers a wide range of pre-made voices, and also the ability to clone voices. For this project, I opted for one of their pre-made professional voices. Once I selected Bartholomew as my preferred voice, I hard-coded its voiceit into my configuration. This voiceit is a UUID that uniquely identifies the specific voice model. Every ElevenLabs.generate call then explicitly uses this voiceit. This is crucial because if I were to just use a voice name, there's a theoretical, albeit small, chance that the underlying voice model might change or be subtly tweaked by ElevenLabs over time, leading to inconsistencies. By using the explicit ID, I lock into a specific model, ensuring that every audio segment, whether generated today or 6 months from now, sounds exactly the same. It's a small detail, but vital for a daily show where listeners become accustomed to a particular sound. The core of the system is the synthesize.chunk function. It takes a text chunk and the voiceit as input. Inside, I wrap the actual ElevenLabs.generate call in a try-except block with a retry mechanism. API calls can fail for various reasons: network issues, rate limits, or transient ElevenLabs service disruptions. I implemented a simple exponential back-off strategy, retrying up to 5 times with increasing delays between attempts. I also made sure to specify the model e.g. 11 multiling UELV2 to maintain consistency there as well. The output of ElevenLabs.generate is an audio stream, which I immediately write to a temporary MP3 file using path ftempchunkIndex.mp3.writeBytes audio data. This temporary file approach keeps memory usage low and provides a clear checkpoint for each successfully synthesized segment, which is important for debugging and recovery. If the generation fails even after retries, I log the error and mark the chunk for manual review. Once all the individual chunks are synthesized into separate temporary MP3 files, the next step is to stitch them together into a single, cohesive audio file. For this, I use PyDub, a powerful and easy-to-use audio manipulation library in Python. I load each temporary MP3 file sequentially using audio segment.fromp3, and then concatenate them using the plus operator. I also add a small, almost imperceptible, silence audio segment.silent duration equals 100 between chunks. This prevents abrupt transitions and ensures a smoother, more natural flow, much like a human narrator might pause briefly. After concatenation, the final audio is exported to a high-quality MP3 using finalaudio.export podcastepisode.mp3, format equals MP3, bitrate equals 192K. The bitrate equals 192K ensures good audio fidelity for podcast listeners without creating excessively large files. Finally, I clean up all the temporary chunk files to avoid clutter. The cost aspect was a crucial consideration. ElevenLabs charges per character. My podcast scripts average about 1,500 words, which translates to roughly 8,000 characters per episode. At my subscription tier, this costs me about $0.07 per 1,000 words. So, a typical 8,000 character episode costs around $0.56. This is incredibly affordable for daily high-quality audio production. If I were to manually record, the time investment alone would far outweigh this cost. Over a month, this comes out to approximately $17 for 30 episodes. This is a very predictable and manageable expense, making the automation not just efficient, but also highly cost-effective. The system ensures I'm only paying for the characters I synthesize, and the chunking strategy helps manage any potential errors before they rack up large character counts on failed attempts. Error handling and logging are paramount in any production system. Beyond the retry mechanism for API calls, I implemented robust logging using Python's standard logging module. Every step, from script chunking to audio synthesis and final concatenation, is logged. Critical errors, like an API call failing after all retries, or an issue with audio file processing, trigger specific error logs that I can monitor. I also track successful syntheses and the character count for each. This provides a clear audit trail and helps me quickly diagnose issues. If an episode fails to generate, the logs tell me exactly which chunk failed and why. This prevents a complete system failure from turning into a mystery and allows for quick manual intervention if necessary. A fully automated system doesn't mean it never breaks. It means you have the tools to know when and where it breaks. This entire system is now integrated into my broader daily content pipeline. A cron job triggers the main Python script every morning. It pulls the latest news script from a local directory, processes it through the ElevenLabs pipeline I've just described, and then places the final MP3 file in a designated upload folder. From there, another script handles the actual podcast hosting platform upload. The result is a consistent, high-quality daily podcast episode, entirely hands-off. It's a real example of how a few hundred lines of Python, combined with a powerful API like ElevenLabs, can completely automate a creative process that used to take significant manual effort. If you found this breakdown useful for your own automation projects, or if you're building similar pipelines, consider subscribing. I'm aiming for 10,000 subscribers by the end of the year, and your support helps me continue sharing these real-world builds. Next time, I'll be diving into how I integrated Claude to automatically generate these initial daily news scripts, effectively completing the entire content generation loop.